Hello everyone, welcome to my channel. Today we are going to study thin layer chromatography, commonly known as TLC. It is one of the simplest, fastest, and most widely used techniques for separating and analyzing mixtures. In this video, I will explain the introduction, principle, methodology, RF value, advantages, disadvantages, and applications of TLC. TLC is also known as open column chromatography, as instead of using a closed column system, we are going to use open system that is in form of TLC plate. It is also known as drop chromatography because we will use one drop of the sample. It is also known as strip chromatography, as after the separation technique, we will achieve or we will get the individual components in the form of strips or distinct bands. It is also known as spread layer chromatography, as in this, a firm or thin layer of stationary phase is spread on the TLC plate. It was first discovered in 1938 by the scientists Ismailov and Schreiber. They have separated the plant extracts and they have used 2 mm thick and firm layer of alumina, and the separation was achieved on a glass plate. In 1958, Stoll has introduced TLC as a procedure of analytical adsorption chromatography, and he has developed the standard equipment. He has developed the standard equipment for analyzing TLC. Before we begin, let's quickly revise the basic concept of chromatography. The principle of chromatography is differential migration. This differential migration means different components of a mixture move at different speeds because they have different affinities. For example, some components are more attracted to the stationary phase while others prefer the mobile phase. And this difference help us to separate them. For example, if we will see the affinity, every component has different affinity. If we are going to check the affinity of individual component towards the stationary phase, if affinity is more towards stationary phase, then that component will move slower, and if affinity is less towards the stationary phase, then that component will move faster. And similarly, if we are going to check the affinity towards mobile phase, if affinity is more towards mobile phase, the component will move faster, and if affinity is less towards mobile phase, the component will move slower. This is the basic concept and basic principle of adsorption chromatography. Let us begin with the introduction of thin layer chromatography. It is a type of analytical technique or analytical chromatographic technique which is based on principle of adsorption. We have discussed the principle of adsorption in previous slide. It is based on affinity towards stationary phase. And in this technique, a thin layer of some inert material is the stationary phase. Thin layer of some inert material is made from slurry of its powder in suitable inert solvent. The term inert is used because this stationary phase has to be mixed in some solvent, Both of these should be inert so that they do not interfere with the sample components which have to be separated. And this technique is used for separation and identification. TLC can be used for various purposes like separation of amino acids, separation of proteins, separation of various drugs, pharmaceuticals, etc. And this will also help in identifying these separated components. So let's discuss about the principle of TLC. It is based on adsorption. We have to take one or more compounds which have to be separated, and these compounds are spotted on TLC plate, or we can say thin layer of stationary phase coated on TLC plate. After this, the mobile phase flows through due to capillary action. We have to place it in development tank, and here is the mobile phase. This mobile phase will flow through this TLC plate through capillary action, and the components move according to their affinities towards the stationary phase. If the compound has more affinity towards stationary phase, it will travel slower, and if the component has less affinity towards stationary phase, it will travel faster. And hence the components are separated based on their affinity towards stationary phase. Now let's discuss about the methodology of TLC. It is also known as the experimental technique used in TLC. The points covered in experimental technique that we are going to discuss in the upcoming slides are stationary phase selection, chromatographic plate or TLC plate, preparation and activation of TLC plate, application of the sample, development chamber or development tank, selection of mobile phase, development technique, and detection by using detecting or visualizing agents. So according to the experimental technique, firstly we have to select a stationary phase. And this stationary phase, after selection of the stationary phase, we have to select a TLC plate or glass plate. And in third method, we have to coat this stationary phase on this TLC plate. And after coating on it, we have to activate this TLC plate. And in the next step is sampling technique, or we can say application of the sample. It is generally done by the capillary tube. Then the next step is development tank or development chamber or TLC chamber. Next step is selection of this mobile phase. The mobile phase which will be run for the separation technique or for the development of this chromatogram. We have to select this mobile phase. Next technique is the type of development technique, whether it will be one dimensional development or it will be two dimensional technique. And last one will be detection of the separated components. First step is stationary phase. Stationary phase is also known as adsorbent or coating material, since we have to coat this material on a TLC plate. The choice of stationary phase that we can select are silica gel G, silica gel H, silica gel GF, alumina, cellulose powder, calcium phosphate, magnesium trisilicate. All of these can be used as a stationary phase. But for preparing the slurry of this stationary phase, we have to mix this stationary phase in water, and the ratio is given like, if we are going to use silica gel G, then we have to take 1 unit of stationary phase and 2 units of water. In this way, we are going to prepare the slurry of this stationary phase. And in silica gel G, G refers to the binder. Binder is gypsum. The full form of G is gypsum, and gypsum has the formula calcium sulfate dihydrate. Next point is selection of TLC plate. Usually a glass or aluminium plate is selected. We can also use the pre-coated TLC plate which has the base plate of aluminium, already coated with stationary phase. And generally we are going to use microscopic slide as our glass plate, and we will coat it with silica gel G slurry. Next step is preparation and activation of TLC plate. For preparation of TLC plate, any of the following methods can be selected. In pouring technique, slurry is poured onto the TLC plate and then spread uniformly, and after that it is dried. In dipping method, two plates are dipped in slurry and then separated and dried. In spraying method, the slurry is sprayed using the sprayer. In spreading method, a TLC spreader is used. Usual diagram of TLC spreader is given. It consists of reservoir in which the slurry is filled, and a base plate is used for holding the trays or the TLC plates, and it is rolled once for the application of slurry onto this TLC plate. Next point is activation of TLC plate. Activation of TLC plate means we have to remove the moisture content or water content present in TLC plate. And for this removal of water or moisture from TLC plate, it can be done by heating it at high temperature. Heating is done by using a desiccator or thermostatically controlled oven. So the next step is application of sample. The sample is applied as a small spot or a thin line near the bottom of the plate. It should be very small, concentrated, and applied carefully with the help of capillary tube. Otherwise, the spots will spread and give poor separation. And after the preparation of TLC plate, we have to mark this origin line or starting line with the help of pencil. And after marking this origin line, we can apply the sample at equidistant point. Equidistant means at equal distance. These sample spots should have equal distance between them. After applying the sample, the plate is placed in a closed container called as development tank or development chamber. This chamber contains mobile phase which rises in upward direction on the plate and carrying components with it. This will cause the separation of component from the sample mixture. Next point is selection of mobile phase. The mobile phase is simply the solvent or mixture of solvent. The choice of solvent is very important because it controls how well the separation occurs. Choice of solvent depends on the nature of substance to be separated and the mode of chromatography that has to be used, whether it will be normal phase chromatography or it will be reverse phase chromatography. And we can choose the mobile phase according to the polarity of our compound. Next point is development technique. Development refers to the movement of solvent up the plate. For example, if this is development tank and TLC plate is put inside it, then the movement of this solvent in upward direction, that is, it will flow against the gravity. It is known as development. And once the solvent front has traveled a sufficient distance, for example, if this solvent has traveled up to this distance, it is known as the solvent front. And if this solvent front has traveled a sufficient distance, we can remove the plate from this chamber. And at this point, we will mark the solvent front with the help of pencil, as this solvent will evaporate quickly. And the development technique is of two types. It can be either one dimensional or it can be two dimensional. One dimensional technique is vertical technique, two dimensional is known as horizontal technique. And in one dimensional technique, plates are kept vertical and solvent flows against gravity. This occurs because of capillary action. And in two dimension technique, it is carried out for complex mixture. Firstly, the plates are developed in one axis, then dried, and then developed in other axis. Last step is detection by visualizing agents, or we can say detection by detecting agent. Detecting agent or visualizing agent are the agents or substances or solution which are used to see the spots in TLC plate. If the spots are colored in nature, we can directly visualize them without using any visualizing or detecting agent. But in case we have obtained a colorless spots on TLC plate which cannot be directly visualized, we can use either specific method or we can use non-specific method. Specific method refers to specific reagent for specific type of entities which have been separated. For example, for amino acids, we can use ninhydrin solution. Similarly, ferric chloride can be used for phenolic compounds, the compounds which contains phenol in them. And drag and drop reagent can be used for alkaloids. These are specific reagents for specific category of drugs. And if we do not know about the category of drug, then we can use non-specific method which consists of iodine chamber, sulfuric acid spray reagent, and UV chamber. These are the type of detecting or visualizing agents that can be. Now that we have separated the spots, how do we actually analyze the results? For this, we calculate something called as RF value. RF value is retention factor value or retardation factor value. It is calculated by the formula, that is distance traveled by solute from origin line divided by distance traveled by solvent front from origin line. It is calculated for identifying the spots and for qualitative analysis. And in case the solvent runs off from the TLC plate, then we can calculate this Rx value, which is given by distance traveled by sample upon distance traveled by standard. And if the RF values of two components are very close, in that condition we will calculate the RM value, which has the formula log 1 upon RF minus 1. This simply gives a ratio that helps us compare different compounds. Next is advantages of thin layer chromatography. It is quick, easy and inexpensive technique, and it comprises of simple equipment, low cost. It is a simple method, rapid technique. This technique has wide choice of stationary phase as discussed in choice of stationary phase topic. The spots that have been obtained in TLC plate can be easily visualized by using various detecting or visualizing agents. And this technique needs less mobile phase, stationary phase, and time. Also, in this technique, corrosive spray reagents like sulfuric acid can be used as it won't destroy or damage the plate. And by this technique, any compound can be analyzed. Next is disadvantages of TLC. First one is low sensitivity as compared to HPLC. With respect to HPLC, it has low sensitivity. Humidity and temperature can affect the result. It is very important for the activation of TLC that we need to maintain. It should be moisture free or water free. Next one is it is not suitable for volatile compounds. Compounds can evaporate at room temperature. Also, the plate length is limited. That is, highest plate length that we can use is 20 into 20 centimeter. If we have to run chromatographic plate for more than that, we cannot achieve that. In this technique, separation occurs in open system, so contamination chances are there. Edge effect can also take place in this type of technique. It is only for qualitative analysis, we cannot quantify the components. And also the recovery of separated components is not possible through this technique. Last topic is applications of TLC. There is no limit to compounds that cannot be analyzed by TLC. A few of compounds I have written here: separation of mixture of drug of chemical origin or biological origin, like plant extract, carbohydrate, vitamins, antibiotics, proteins, alkaloids, glycosides, etc. All these can be separated and identified by using this TLC. It is also used for identification of drug and related compounds of drug. We can also detect the presence of foreign substance or impurities of drug through this TLC. and it can help us to detect the decomposition product in drug. So this was all about TLC from my side. Thank you for watching. I hope you will like the video.